Hello everyone, welcome to lesson number 23 for BC Calculus, where we're talking about Taylor-Maclaurin series. In this video, we're going to talk about some extra problems that have not necessarily talked about in our notes. And the very first question here, solve for x, where x minus x cubed over 3 factorial. And you can see that this chain right here, and hopefully you guys realize what this is. So you'll see a question where you're trying to solve for x here, and notice that this is the plus, means it's going to keep going on and on and on. So you guys can see that this is a Maclaurin series where c is equal to 0 for sine. So this is the sine of x. We also notice that there's a power of 1 here. The degree and the factorial are the same value. So we know we have not manipulated sine. Our values are changing, right? So our second and fourth values are negative. Our first and third are positive. And so we know that this actually equals sine of x. This is a Maclaurin representation for sine. So we set sine of x equal to 1, and then we talk about, okay, well, what values is sine equal to 1? And so when we go through the problems here, we can just say that x is going to be equal to pi over 2. Now, this can be one of our answers. We have a general idea of what else it can be. So we can't say that it's going to be 3 pi over 2 because that would be negative 1. So it'd be pi over 2 and then any coterminal angle for that. So we can do plus or minus k of 2 pi or 2 pi k. And that could basically give us back to what we want. So this is the answer to this problem. Now, if we look at question number 2, it says that we're seeing this function here and we want to know what the function is. So the real rule of thumb for this is the fact that the degree and the factorial does not match up. So what I could essentially do, and I'm just going to show you guys in our second term right here, is I could do x times x squared over 2 factorial. So I can go ahead and just pull out an x. If I go to the third term, I can also pull out an x, and so what I'm left with is x to the fourth over 4 factorial. So you guys can see it even in this one right here, this fourth term, I can go ahead and pull out an x, and I'm left with x squared, or x to the 6 over 6 factorial. So the power of this is that I'm actually having my exponent and my factorial to be the same. So for all of these examples, and even for this one, it would just be x times 1. So I can rewrite this as x, and I can just undistribute the x, and so I'm now left with 1 minus, because I'm keeping the sign here, so it's going to be x squared over 2 factorial plus x to the fourth over 4 factorial, and then minus x to the 6 over 6 factorial. So this is actually helpful for us because we can now recognize what this is. So this is going to be cosine of x, and then we just have to multiply it by x. So this series is actually going to be the cosine of x times x, so the manipulation of cosine of x times x. All right, so let's do another example that's very similar to these two. So if you guys look at now example number 8 here, we have actual numbers plugged in. So we want to know what the actual number is. What's the actual sum of this? So first thing that I notice here is that I can replace with my 0.2. So I'm going to go ahead and call x equal to 0.2. All right, and so I'm going to go ahead and call that x so that I can go ahead and rewrite every 0.2 as x. And so now what I'm left with is 5 minus 5x squared over 2 factorial plus, and I'm going to show just a couple of these because you guys see the idea of this. So you guys can see now again, just like from the previous example, I've got my degree that's equal to my factorial. So I could pull out a 5, and again, I'm just doing the first 3 terms here, and I'm going to be left with 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial. And so again, as beforehand, we talked about this right here is going to be our cosine function. So it's actually going to be more specifically going to be cosine of x. We have a 5 here, so we can go ahead and say that this system, this series is going to be 5 cosine of x. So the actual numeric value that we're going to get out of this is going to be 5 cosine of then 0.2, right? Because we have to substitute back in what our x value is. So this is going to be 5 cosine of 0.2. And so we're going to use a calculator for this problem, and we're going to get that this series is going to approximately sum up to 4.9003. All right, so using that same strategy, we can go down to the bottom part here and again say x is equal to 0.2. And so then we can go ahead and rewrite these as x's. And then you guys can see that we have an x squared minus, and again, x to the 4th over 3 factorial plus x to the 6th over 5 factorial. And so, again, like the previous examples, we can pull out an x. So let's undistribute an x here. And the goal is when we do that, we would like to be able to, what's left in these parentheses is just a polynomial that we are comfortable with, that we actually know what it is. And so just like in the previous examples, we can recognize this as sine of x. The sine of x. So this is going to be equal to, and again, we have our x here. So this is going to be sine of x times x. So the manipulation is x sine of x. So we can go back here and substitute in 0.2. So we're going to do 0.2 sine of 0.2. And then again, if we use our calculator for this problem, we're going to get 0.0397. So that's how we're able to rewrite these functions into something that we're able to solve using series. So let's continue on with kind of the idea of what we've talked about in the previous examples. So now it's asking us to find the Taylor series for g of x, where it's equal to x squared cosine of x about x equals 0. So again, this is the Maclaurin series of this function. And let's just say for the purposes of this that we want to go to the third term. And so this would be something that I would give you, so the third term. Now, what some people can do is they would find the derivative using the product rule and then do the product rule again. That's really crazy. There's a much easier way to do this problem, quite simply, is if you take the Taylor series or Maclaurin series for cosine of x, which you guys know is going to be 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial, right? And again, I'm doing 3 terms, so there's our third term, so 1, 2, 3. And then all I'm going to do now is I'm going to take this and I'm going to multiply both sides by an x squared. So this is an easy way of getting this series without having to go and find the first derivative and using the product rule and plugging in 0 and doing the second derivative. This is such an easier way to do it by just simply manipulating it. So write out your chain, your series for your cosine, and then just multiply every term by x squared, and that's going to give you the answer that you want. So x squared cosine of x is going to be equal to x squared minus x to the 4th over 2 factorial plus x to the 6th over 4 factorial. And this way, you guys can see that if I give you this now, based on the video that we've talked about, we can now say, oh wait, this doesn't match. There's a 4, there's a 2. I can probably factor out an x squared, and that's exactly what you would do. And you would get back to what we've done here before. So this is going the other way with the problem. All right. Okay, so to tie in our last example of manipulation and what we've talked about with rewriting stuff, we want to find the 6th degree term for the Taylor series of sine of x squared minus cosine x cubed about x equals 0. And again, 6th degree, right? You don't want to have to find the 6th derivative of this. So just like before, if we look at the Taylor series for sine, we know that that's going to be x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. So that's the idea of what we want. So we're going to manipulate that. We're going to go ahead and replace all of our x's with x squareds. So we're going to have x squared here, and then we're going to have minus x squared cubed over 3 factorial. I'm going to stop there because this is going to give us our term. It's going to be negative x squared over 3 factorial. So I know that this piece of the puzzle is going to be negative x to the 6th over 3 factorial. And that's very straightforward, simple way of finding the problem. Over here, let's look at cosine of x cubed. And so manipulation. Well, what is cosine? Well, cosine is going to be 1 minus x squared over 2 factorial plus x to the 4th over 3 factorial. Oh, sorry, x to the 4th over 4 factorial. And so if we manipulate this one, then it's going to be everywhere we see an x, we're going to put an x cubed. And so I'm going to stop right here because this is going to give us negative x to the 6th over 2 factorial. So that's my 6th degree. So I'm going to do minus a negative x to the 6th over 2 factorial. And then all I have to do here is just really simplify this. And that's really all that we need to do to solve the problem. So this is going to be a negative x to the 6th over 6, right? 3 times 2 times 1, plus x to the 6th over 2 factorial, which is going to be 2. 2 times 1 is 2. And then simplify this. So I have negative x to the 6th over 6 plus x to the 6th. And so if I want to put a 6 here, then I can just put a 3 here, right? This is still 1/2. And so I can now add these together, and I'm going to get 2 x to the 6 over 6, which is going to give me x to the 6 over 3. So the answer here is going to be B. So I hope this video helped you guys. This was just a video about how to rewrite, manipulate your Taylor series. And more specifically in this video, they were all Maclaurin series. So there you go, and I'll see you guys in the next video.